This is lesson 2 of unit 8. In the previous lesson we talked about percent composition of a compound, and in this lesson it'll be a short lesson. We'll apply that concept to a few types of problems. So here's the first problem. A certain compound is 25% sulfur by mass. How many grams of sulfur are there in a 5-gram sample? Now this is a simple problem where we apply percents, and this would be very similar to if I said that half of my class, if I said 50% of my class, there we go, my class are girls, which isn't entirely true. I actually have more girls than guys in the upper level chemistry courses, which is surprising, but go girls. And I'll say I have a total of 24 students. If I have 24 students and 50% of them are girls, how many girls do I have? Everyone could probably say, well, that means I have half of them are girls, which means I have 12 girls. Now, the way you did that is you simply divided 24 by 2, or you applied 50% to 24. So when you apply the 50% to 24, essentially you do 24 multiplied by 0.50. And the 0.50 is the ratio that came from the percent. You actually undid the percent. So if you remove the percent, that means you divide back by 100, you'll get to 0.50, or a half. A percent is simply a ratio multiplied by 100. And that's how we got the 12 girls. We're going to do the exact same thing with compounds now. Take a look at this problem, and it's really the same exact thing. We're saying that our total mass is 5 grams, and 25% of it is sulfur. So let's apply the 25% to the total mass, and we'll get the mass of sulfur. So we undo the percent, so the 25%, if you divide by 100, to undo the percent, you get the 0.25. This is your ratio. This is really what you got before you multiply by 100 to get 25%. So we'll simply take this 0.25 and multiply it by the total. In this case, 5 grams, 5.0. In this case, grams. And if you do this, you will get 1.25 grams of sulfur, which is pretty easy, not too bad at all. So this is really, in a way, reversing the percent formula. If you want me to show you, you can rearrange the percent formula to actually get this. I don't know if this will be confusing or not. We have time, so why not I show you. Let me show you. This is extra material, just for you to see what I've done with the percent formula. Remember that our percent formula is mass of element divided by total mass times 100. So what I'm solving for essentially is my mass of element. So because total mass is being divided, I will multiply that out here, and because percent is being multiplied, I'll divide by here. So here's what I end up with. Percent divided by 100, that's what I just did, and then times the total mass will give me my mass of element. And now notice what I did in this problem. My percent is 25, so I got 25 right here, divided by 100. My total mass is 5.0. Here it is, 5.0. And if I solve this, I'll get my mass of the element. 25 over 100 is 0.25, times 5 is 1.25 grams. So really, I just rearranged the formula again. If this is extra, this is confusing, don't worry too much, but I thought I'd show you the trick. Let's do one more problem. Before we do that, go ahead and try one on your own. It's really applying the percent to the total mass. Should be simple. And now let's do this final example. This final example says how many grams of carbon are there in 17.2 grams of carbon dioxide. Now, to get the grams of carbon, what you would do is you'd first find the percent of carbon, and then you would apply that percent to the total, just like we did in the previous example. So we essentially combine the two types of problems. Now there's a really quicker way to do this. Let me do it in a longer way and then a shorter way. So the first thing, to find the percent of carbon, we take the mass of carbon. Let's first find the percent. The mass of carbon, which is 12.01 grams, divided by the mass of the whole thing. Now the mass of the whole thing, we have 1201 for carbon, and we have 1600 for oxygen. There are two oxygens, so the total mass should be 4401. So this is the total mass. And we'll do that on the bottom. So 4401 goes on the bottom. And then don't forget to multiply by 100 and do this calculation. 12.01 divided by 44.01 times 100 gives you 27.29% carbon. So we've done this before, and now we apply this percent to our total mass. Our total mass is 17.2. So we'll undo the percent by dividing it by 100. Now if you divide this number by 100, effectively you're just moving the decimal place twice to the left. You can try it. I'll go ahead and set it up. 27.29 divided by 100. You get 0.2729. And then you multiply this number by the total. And the total is 17.2 grams. And if you do this, you'll get yourself the number that we're looking for, which is 4.69 grams of carbon. This is our final answer. So 17.2 grams of carbon dioxide contains only 4.69 grams of carbon. Most of it is oxygen, which makes sense because we have more oxygen in this case. Now let me show you the quicker way of doing this. You could actually set it all up in one problem, and that is you take the total mass, which is 17.2, and you multiply it by the ratio of carbon to the total, really, of this factor right here. So carbon is 1201 in the compound, the total mass is 4401, and if you do this, you'll get your 4.69 grams, just like we wanted. These should be equal. What you're doing essentially is you're multiplying the total mass by the ratio of the element mass to the total mass. If you stop and think about the logic behind this, hopefully this will make sense. It's the total mass times the ratio of the element in that compound. And this will save you the steps. So you're essentially, in this problem, we're combining example 1 and 2 in this example 3. So take a minute to think about it, and then to help you practice, go ahead and try one of your own, this practice problem here. And this will conclude for us lesson 2 of Unit 8.